Awesome. Cool. So it's nice to meet you all. My name's Mitch. And as Chris just said, my background is in teaching, and I currently work at Northcoders as a developer and also a lot as a lecturer too. So what I've brought together in this presentation kind of fits in nicely with what people have been talking about already, about kind of metacognition and examples. What this is basically is a set of ideas. It's kind of opinionated because I've come up with them and stitched them together about the kind of mechanics, if you like, or an approach you could take if you're kind of developing content, which I think that was something Louise mentioned in the breakout room earlier, which is kind of like generating content. So, because if you're going to get a show of hands from people, how many times have you come to a lesson and thought, you've got a blank piece of paper and thought about how you start? Okay, anybody had that problem before where you have like a new concept and you just don't know what to kind of like start or have it in? So this presentation is designed essentially to give to kind of like people who are starting at Northcoders, new lecturers if you like, to kind of give them a process for kind of thinking about that to some extent. So it's called motivating explanations, but you could be called constructing explanations or something like that. And it's my kind of like mini take on it if you want. So first thing that hopefully you can all see on there is like a kind of spectrum, if you like, that start off with thinking about, which is a spectrum between discovery and declaration. What does that mean? Okay, in terms of kind of learning something. So the example I could give you, this is my favorite toy. I'm currently in my office at work, by the way, in case you're wondering where I am, is this. Draw this out. Hopefully that picture will remind you of something from school, maybe giving you flashbacks. Anybody think in the Zoom group chat, what does this remind you of? It's very difficult perhaps to work out immediately what this looks like. It's meant to be a right angle triangle. Yes, it is. It's a paper airplane. This is Pythagoras theorem, but it could have been anything. Cool. It's a very bad triangle. I do apologize. I should put that in to make it clear what that means. So what are the two ends of the extreme here, if you're thinking about learning? So the end of the extreme for discovery is if you are Pythagoras himself in ancient Greece, okay? So you come to just to discover this by yourself, okay? That is the one extreme level that you could be on. The other extreme over here is probably what some of you will have experienced at school, perhaps if you have a teacher who is, shall we say, on the strict side, who could just say to you, square of the hypotenuse is equal to the sum of the square of the remaining two sides. Off you go. Here's 50 exercises on how to do that. The declaration is where I tell you how to do something without any kind of thought. I go, here is a new piece of knowledge that I impart to you like that. So on the very other end of the spectrum, if you like. So obviously there are problems with both of these approaches. Anybody think what are the negatives on this side of the scale for discovery? It could be any concept, by the way. It doesn't have to be Pythagoras. It could be something to do with coding, which I'll bring it back to in a moment. It takes a long time. That's the main fit here. So it could be time for this. Do not know how much time it takes for you to discover Pythagoras theorem or anything for anybody. Frustrating for people who aren't successful in discovering, yes. If you are discovering something, it is a potentially messy process, okay? It requires exploration. It could take a very long time indeed. So that is not good. What are the positives though for that on the other side of the spectrum? What are the good things about being over here? You can unmute as well, folks, as well, if you want to. Yes, exactly. Lots of good suggestions here. People are saying, people can also unmute if you want to. That's when you really get it. If you discover something yourself, then ultimately you understand that, right? Okay. Problem is that is potentially very, very, very time inefficient. Could take a very, very long time indeed before you discover it. Problems with declarations. So this one's pretty straightforward in terms of why this is not potentially good. Any thoughts on this one, folks? For somebody who's had that before, had stuff told at them or talked at them.
I think this is for me. This is a classical how to draw an owl in 2 steps. If you know that one, where you have first step, draw 2 circles, and step 2, you draw the rest of the fucking owl. And I'll send an image so because it's easier to see what I mean. But sometimes it's like that. Oh, this is Pythagoras. Now go solve 20 exercises.
Yes, exactly. Yeah. Basically, I give you this piece of information, and that is that. That is the end of the lesson. Yes. The other problem with this is that you don't understand where it fits in. You don't understand how to apply it. Potentially, if I tell you this piece of information straight off the bat like that, then there is no sense. And this goes back to what Richard was talking about just then, about actually knowing what people know. So my kind of like idea or take on this is that for some reason, whatever it's going to be, it's going to lie somewhere in the middle of that line, okay? And because of the time constraint of doing a lesson at CodeYourFuture in a day, or however many kind of like minutes you've got, it's going to be shifted towards that end of the spectrum, unfortunately, because you can't like have a class, certainly remote, where they're just going to discover everything. It is not feasible. But what I try to get across here is steps that you can take to try to improve, even though you're going to shift towards that end of the spectrum. So this is going to be practical. I didn't really ask before, Chris, if people would know, everyone wouldn't be comfortable with JavaScript, but I'm just going to go for it anyway. You don't have to know about it, but here's a kind of practical example of this with a new concept, okay? So understanding the difference between value versus reference. You can basically go off and tell somebody that here is the difference between value versus reference. Arrays are held in reference, primitives are held in value. That's that. How can you shift it towards that end of the spectrum where there's more discovery, but there is, it's still kind of time effective? Some tips for that. So to try to find a balance in the spectrum somewhere. So the way I approach this, and I try to do this as much as possible if I ever have to teach something brand new, is I think of something that acts like a door that is currently locked. And this could be a problem, a question, a scenario, something like that, which I'll give you an example of in a moment. So a problem, a question, scenario, puzzle, something like that, the students are given. And the idea is that the key to unlocking that door in some way will be the new concept. So in this particular example, the key is going to be knowing difference between value versus reference. That's the kind of the new concept, the piece of knowledge. And knowing that will hopefully unlock that door at the beginning. This will make more sense, by the way, when I give you the example, hopefully. So just bear with me for the time being. We start with a door, it's locked. We have a new concept in question, value versus reference, in this case, and it's hopefully going to unlock that door for us till we can solve the problem, whatever it may be. So what would that be in an example? So suppose that I'm thinking about how to start value versus reference, for example. One way I would do that, my door in this particular context would be this. That snippet of code is my door. It's written in Jest, if you've used it before. And I will just basically put that slide up, or I will get that block of code and I would run it on my laptop or my computer. And I would get the students to ponder it for a moment or two. And the reason why I've chosen this particular problem is I've highlighted 3 things on here that this problem will do at the beginning. So this might be like the very introductory part of my lecture or explanation. So the first thing it should do is it should purposefully confound students' expectations or intuition. So the students looking at this, if they've not seen this before, this syntax, 2 and 2b, they may at first be puzzled by why one of these tests is passing and one of these tests is failing, okay? They may not know the answer to that question. So it's going to kind of deliberately get them thinking, what's going on in this question? One of the other good things about that is straight away, you've inverted the kind of the dynamic and you've pushed the question back to your audience. So already they're faced with having to understand something or piece something together. It sets the scene for the start with a question to get them thinking. And also in line with what Richard was talking about in assessment and asking questions to make people learn is, I have this one, and this is perhaps one of the most important points about the introduction in this question. Return to this example to check students' understanding. So I set the scene. I've got a question that at the moment students might not know how to answer properly when I'm comparing arrays like this. They're pondering that. It's not kind of like totally beyond their reach to kind of figure out what's going on here, but they might not understand exactly how to answer why this is not working the way they expect. But hopefully, if they've been taught or they learn that, then they will be able to kind of work out or give me an explanation as to why that is not working in the way they would expect. Can I get a show of hands from people or thumbs up or stuff like that? Or does anybody want to unmute to ask anything about that at the moment? In case it doesn't make any sense, feel free to stop me. I don't want to keep on going. Cool. So then I might kind of actually do my explanation or think about that later on and get to it. But what I'm trying to look for at the end, and this again ties in with what Richard was saying about assessment, is I might try to get towards a dialogue that looks something like this. So at the end of this, I might go back to this example after having talked a bit about value versus reference and say, okay, folks, can anyone suggest why this example is working now? And from previous experience of doing this, you will normally get people who will say that the second fails because you've got 2 different arrays or 2 different locations in memory, something like that. And it means that it goes back to what, I can't remember who it was exactly. You have to raise your hand. You were talking about whether or not the student is just kind of like parroting what you've just said or mimicking what you've just said without any kind of sense of whether they truly understand it or not. What you're doing here is you're setting up a scenario to really test, to assess whether or not they understand this new piece of knowledge. And that's built into the example from the very start, if you like. Sometimes the tricky thing is coming up with this example in the first place. Something like that to kind of like give you an in when you're thinking about that. Does anyone have any questions about that? It is very difficult speaking to the void, as you said, Mitch. No? Cool? Cool. So question then is to kind of think then of other things that you might want to. This presentation isn't very long, but like here's another one, or a new concept or a topic that I was supposed to be kind of like teaching or telling somebody about, which is, for example, like what is an object for? What is an object for? By object, I mean literally object like that, not arrays like this, object this rule. What is that for? So in this instance, when I have to teach this, my very, very, very first instinct, my personal instinct, I'm not saying that you have to do this, this is mine, kind of like my approach, if you like, so you can take what you will from that, is to think, what is the door to this? Or can I construct a door or a problem that is in some way fixed or corrected by knowing what an object is for, in some sense. And here's what I go to for this. So this is what I'm going to give to the students, an array that looks like this. Anybody want to suggest in the Zoom group chat what students will hopefully pick up on when they see something that looks like this, which is my door at the moment. This is my problem. Yes.
I
Sorry,
can
go
pick
on.
up if you want to. Yeah, I was gonna say, like, people would probably pick up on how do we know what is what
Yes.
from those values in the array.
Exactly. That is problem number one. You've got an ordered collection of data, so we can store multiple bits of data. But as Antigone just said then, we don't have any sense of what each piece of data is for. And then I'll tell them this is my data about my mum, and then I'll get them to try and guess what each bit of the array is for. And then we'll say immediately we've got a problem on our hands.
Yeah.
The actual explanation bit, okay, there will come a time where you have to say to somebody, this is what an object looks like. This is what a key value pair looks like. But at the end, what I will do is loop back to this example, and I will say to somebody, what would be a better way of storing this data? How would it look? Write it down.
Here's what I found.
That's Google. I'm on my phone. Here's what it found. So, and then I could literally give to the students a minute to say, create those details in a similar way. So I might say to them, oh, well, this is a first name. This is a last name. And again, going back to what Richard was saying about questions, automatically, from the start of the lesson, this question is posed. Now it's up to the learners to digest that piece of knowledge and to see if they can apply it to this context and fix the problem in the first place, which goes back to this notion at the beginning. Okay, the door in this case is the array. We've got this problem of storing data. We don't know exactly which bits are. The key in this context is being able to understand objects' literal syntax and storing key value pairs. And by the end of it, the door that they should have opened is being able to store data in that way. Now, the issue with this kind of approach that I find is sometimes it is difficult to come up with an example like this. So do people kind of agree or disagree that like coming up with a good example like this is tough? I find this very tough indeed. But it requires kind of a lot of kind of research sometimes, or thinking around, or digging around, and then maybe you get there in the end. But it isn't always easy to do it this way. So I'm not saying that this approach is necessarily the best, but that is just my kind of take on what I try to look for as a kind of an entry point when I'm teaching something brand new and thinking about what can my learners digest in order to kind of like unpick this problem that I've given them. Cool. Does anybody have any questions about that? Because I'm done now. It's the end of the session.
All makes sense. Thank you.
Just a quick comment that I would love if collectively we could put more of this into the syllabus. Like I love this approach and would love us to like write down and share our examples, because I'm sure we all have some.
Yeah, I've got a little bank of these examples like hiding somewhere on my in the depths of my laptop. So I'm happy to share those.
Could you use the door as a problem as well that you see repeated over with students? Like at the moment in the application phase, all the students seem to struggle with the nav bar being in a fixed position. So I've seen that multiple people, so I can see that they don't understand that concept. Is it too obvious to use that thing that they're all struggling with as the door to teach, for example, position fixed and, you know, or not?
No, I think that's actually a really good point, is that you can take what they don't currently understand and turn that into the problem that you give to students and say, look, this nav bar isn't working in the correct place. This is the problem that we have to solve. And that's basically taken from their experience. And then you can basically say, okay, this is what we're going to do in order to fix this problem. So yeah, that's a good example. And that's more practical based one, but yeah, definitely.
I've got a question. Is it mean to ask questions that are like gotcha? Like asking what the, for example, in an array, dot length, that index, what would it return? So obviously it will.
Is it that's a good question, right? So you don't want to kind of like embarrass people or make them feel stupid by asking them a question that you know, like asking them what is, you know, the length of an object or something like that they know that they're probably not going to get right. So I think it's about creating an environment where where they kind of almost anticipate or expect to be in a position where they will get something wrong. So I will often say to people, here is an example. Can I have a show of hands? Will it be A, will it be B, or will it be C? And so there's less, but it is difficult sometimes. I think it's just trying to create an environment where people feel comfortable knowing that their expectations might be off slightly and that they're afraid to kind of make a mistake. But yeah, it is difficult. You don't want to kind of make people suddenly feel, I don't know anything. But yeah, that's a good point.
Well, I think that's something we should all be cultivating, that the safety to be wrong. That's super important, however we're approaching the material and the assessment.
Yes, yeah, I agree, absolutely.
To come back to a book that Richard talked about, Doug Lemov's Teach Like a Champion, he has various techniques, and on each of those he'll talk about, you know, bringing out the positive in the student's contribution. So like in cold calling and some of the other ones, definitely worth a look there at some of, I mean, that's for high school teaching generally, but still applies.
Cool.
A lot of that material's free online as well.
Awesome. Cool. No more questions, then I'm done, Chris. So thank you for listening, everyone.